Hi, I'm Spencer Krause. I've been building robots for over 20 years. In that time, I've seen a lot of interesting things, and I've heard a lot of interesting stories. Collaborative with Spencer Krause is a place where my colleagues and I can relax, crack a drink, and talk about some of the crazier things we've seen at work and some of the experiences we've had that have gotten us to where we are today. Subscribe today to join the collaboration. Welcome to the Collaborative Podcast. I'm your host, Spencer Krause. Our guest today is Kevin Carlin. Kevin is the Chief Commercial Officer for Realtime Robotics, a company that's making interoperability that actually works for industrial robot arms. Kevin, welcome to the pod.
Thank you, Spencer. Great to be here.
Good to have you. I've been by your guys' spot in Boston a couple of times. Awesome setup, awesome demos. I always enjoy the visits.
Yeah.
I'm glad you're here in Pittsburgh. Good to have you in my hometown.
I know. I'm so glad to be here. We've been planning this for a while.
Oh, yeah. No, it's been a long time coming.
Yeah. It's good to be in Pittsburgh, getting to see it properly for the first time. And there's this wonderful collaboration between Boston and Pittsburgh and the robotics scene. So great to be here. Thank you.
Hey, it's my pleasure. Glad to host you. Glad you're here for the event that we're at right now. And I only don't say what it is because this is going to come out like a little bit after, and I want it to still be topical. But how did you get involved with Realtime Robotics?
Wow, that's a bit of a long story. Well, Realtime, being Boston-based, I was working in semiconductor for many years, and I have some connections into the robotics scene and to the Mass Robotics organization, and some new VCs up in the robotics space in the Boston area. And I was aware of Realtime Robotics, but they introduced me to Realtime Robotics. They were looking for someone like me, and it was when I looked at the technology in more detail, I got really excited about it, because I've been in that, not really directly in the middle of it, but involved in, let's say, the automation space across globally, but doing a lot of work in Germany. I was based in Germany for many years, and then in the US as well. So strong familiarity with the robotics industry, but the tech as well. And then when I was introduced to Realtime Robotics, and they kind of filled me in terms of what they had developed and the promise of the whole thing, I was really excited about it. And so they created an opportunity for me to come over, and I took it. Yeah.
That's awesome. And you were at Analog Devices before, right?
Yeah, 13, 14 years at a wonderful company, ADI. Started with them out in the Munich area, and then came over to headquarters and did a lot of different things for them. But that got me introduced to the whole robotics scene in Boston. So, and that's led me here. So it's been a wonderful journey.
That's awesome. No, I love Boston. I feel like Boston is arguably a town that has more going on in robotics than Pittsburgh, and probably the only one. So I'm jealous of kind of what you guys have going, but also I think we complement each other nicely. I
think so. Actually, a few years ago when I started out with Realtime, I thought Boston was the hub, only to discover that actually there was a growing scene here in Pittsburgh. And it's tremendous to see what's happening here.
Thank you.
And Carnegie Mellon, of course, being central driver of that historically, and now I'm seeing the let's say the sharing and the communication and the cooperation between Boston and Pittsburgh in this scene is only going to strengthen both of them, which is great.
Oh, it's been wonderful. We've got 3 Boston-based engineers on our team at SKA Robotics.
There you go.
Yeah, you guys are the best.
Great. Take that.
Hell yeah. So tell me a little bit more about like what it's like working at a relatively young startup, I guess, versus like a larger company. So I imagine there's probably was a bit of initial culture shock, but you've been at RTR for a while now.
3.5 years at RTR. Big change, obviously, going from very large corporate culture to startup, both with their pros and cons. But it was fresh, and it was it kind of regrounds you where when you're a big corporation at the level that I was at and some of the roles that I had, you've got, state the obvious, you've got armies of people around you. You've got teams, whether it's legal or finance or administrative and so on, that take care of all of those things that you concentrate on your business, you can concentrate on your organization. And obviously when you go to the startup, it's like you're wearing all hats. And what's wonderful about the startup is it's exposing me to something completely new, especially on the fundraising side, on the investment piece of it. But you've got your finger in every pie within the corporation, and you get to make decisions a lot faster and operate a lot quicker. So it's wonderful. I love it.
The best.
Yeah, yeah. It's very refreshing. Yeah.
I love, being in a small company, SK Robotics, that does work with a lot of larger companies. I feel like it's nice because you get to kind of taste both worlds. I feel like, you guys are in a similar position with some of the markets you're into. Do you still enjoy kind of interfacing with bigger companies, but from a more nimble position?
Yeah, throughout my entire career, I started out, I graduated as an electronic engineer.
Oh, cool.
And post-grad as well. And I was guided into kind of technical sales, which I felt really comfortable with. And so throughout my entire career, I've always maintained close contact with customers. I find that to be the most rewarding part of the job, and any type of customer at any stage. And so it could be large corporation, C-suite engagements, all the way down to the full technical and operational side of things. So I've always maintained, I've always made sure that whatever role that I'm in, whether it be large corporation or startup, that I'm interfacing with customers. It's so rewarding. Yeah.
Yeah, it's the best.
Yeah.
It's been interesting in my career because I feel like as I transitioned from engineer to manager, more to sales, it's kind of my arc. I always enjoyed interfacing with other engineers, and I think that I turned that inward to the team for a lot of my career. But recently, you get the same joy, if not more joy, I think, interfacing with customers, and it's pretty much the same thing. You're talking to people that have real problems, and you're helping them solve them. And it's one of the most rewarding things in the world, in my opinion.
It really is, and more often than not, that every customer, no matter what industry you're in or what you're trying to do, there's commonalities between them all. It comes down to solving their problems and removing obstacles, and really listening to them, really understanding them, instead of trying to sell something to them. And I find that to be the most effective way to communicate with customers. The trust builds up pretty quickly. But you get such a variety as well. You get to travel. You get to engage with customers across different industries and applications. You're always learning something. Never gets old. Yeah.
That's the best.
Yeah.
So, obviously you're a pretty worldly person. You were telling me about this in the car, but just for people listening, for context on your career, what are some of the places you've lived throughout your life?
I've moved around a little bit. Might not tell by the accent, but I originate out of Belfast, Northern Ireland, and grew up there through those troubling times, but had a good experience, and but needed to venture out, needed to see the world, and after graduating, moved over to the London area. Spent about 3.5 years in England. Met a wonderful lady who's now my wife. Happens to be German. Thank you. And we were both in the same industry. Worked together briefly, and I really wanted to learn German. I knew we were going to get married and be together, so I was intent on learning German. And best place to do that is in Germany. And we were able to transfer over big semiconductor hub in the Munich area. So we lived in Munich, worked hard on the language, which wasn't easy.
How long did it take you to get to the point where you felt like you could actually understand what people were saying around you?
Well, I immersed myself in it from the get-go. So you start picking up bits and pieces, but I reached the point, I didn't have time to go to classes because I was on the road all the time. I was in sales leadership, and it was traveling a lot. And probably after about 6 months, I was talking to customers, I'd give them the opportunity to, speak in their native tongue in German, but if it's okay, I'll respond in English. And they appreciated that. And I remember one time, I was about 18 months in, and I was actually hosting technical workshops, like full-day workshops on certain technologies. And I was invited to do that at a customer location about 4 hours away from where I lived. And I got all the way up there and got everything set up. And I said, okay to do this in English. And they said no. And I thought, okay, this is going to be interesting. Now it's technical, so you kind of, there's English mixed in. But anyway, I said, guys, this is going to be a long day, but I'll try my best. And I muddled through it. And on the ride home, the 4-hour journey home, I realized that I should be doing that more often. And it turned out to be a confidence thing. And from that moment onwards, I switched 100% into German, albeit very bad German, but it's the best and fastest way to learn. So after I think it was probably about 14 to 18 months I was there when that happened. And I'd say about 6 months later, I could understand almost everything that people were saying, and I was quite conversational, albeit bad grammar, but I've been working on it ever since. So that was, I spent 12 years in Germany, and
wow.
And then late 2012 moved over to the Boston area with Analog Devices, and been there ever since. So.
That's incredible.
Yeah, thank you.
Yeah, no, that's really cool. I'm sorry, just the language thing. I'm only fluent in English currently, embarrassingly enough, and I feel like the confidence thing is real. I mean, I spent a few years in school doing French, and
yeah, me too.
Yeah, whenever, yeah, exactly. Whenever I'm in a French-speaking country, like, you know, if I have enough drinks, I'll start speaking horrible French, and you know, people eventually tell me your French is terrible. You know, you should probably speak English, or like, you know, they'll play along, and I'll get a little bit better as a result of it. And
if you don't use it, it's never going to work. It's never going to last. And
so you just have to be comfortable looking like an idiot for a little bit.
You've got to. Yeah, you've just got to put yourself out there. And I take every opportunity I can to speak German, whether it be family related, in-laws, and I'm out there at least, 4 times a year, and it's great because I never want to lose it. So just keep chipping away at it.
That's awesome.
Yeah,
that's incredible.
Thank you.
Did you know that Collaborative with Spencer Krause now has a merch store? Please go to cwskmerch.com for the latest in CWSK styles. We've got hoodies, t-shirts, hell, we've even got whiskey glasses. Everything in the store has custom art that our team worked really, really hard on, so go ahead and show your support for them, me, and the rest of the CWSK team by going to cwskmerch.com today. Better yet, support yourself and use discount code PODCAST10, all one word, all uppercase, for 10% off your entire order. Thanks for your support and enjoy the rest of the show. Collaborative with Spencer Krause is sponsored by SKA Robotics. If you're in the market for elite field robotics expertise, please consider hiring SKA Robotics. They sponsor this podcast and solve some of the toughest engineering problems in the world. SKA Robotics can be found at skarobotics.com. You told me that on the way over that like RTR was the second company to incubate at Mass Robotics, which is incredible. Ed Daniel Theobald, one of the co-founders of Mass Robotics, on the podcast. Great dude. Really like him a lot.
That's right. Yeah.
And, I think it's interesting that you guys were the second ones in, but the first ones to graduate.
Yeah, that was a few years before I joined. I think I'm getting that story right. RTR was founded out of Duke University, and the co-founders are still with the company, either on the board or senior technical staff. And Mass Robotics was right there in the seaport, in the waterfront, and
that's a great location.
Yeah, and the decision at the time of the CEO, Peter Howe, was to move the company up to Boston because, partly because with the robotics scene in Boston and Mass Robotics, so the sport was there, and your access to talent, and of course the big colleges. So that was a great decision. They had the shared office space up at Mass Robotics. They were given access to that community, and I believe RTR was, I think, the second company in there in the facility, but the first to leave, which is a good thing, which is the whole point, right? So
yeah.
you stand on your own 2 feet and you move out. We moved over to a wonderful facility, still in the seaport. You've been there. You've seen our demo area, etc.
It's a lovely setup you guys have there.
Yeah, it's a fantastic location. So if anybody's in the area, come and see us.
You're so good about that. Like I remember, I think that's how we met was a couple of years ago at the Robotics Summit and Expo, and
Yep.
it was you or a colleague. I believe it was you that invited me in for a demo.
Right. Yeah.
And it was incredible. I mean, you had robots from 4 different manufacturers, which I don't know if anyone's worked with industrial robots that's listening to this, but like to get those things to cooperate with each other is no easy task. I mean, everything's got its own proprietary language. I mean, by design, like the business models of a lot of these companies is like, I only want to work with stuff from my same brand. So whether it's like, Fanuc, Yaskawa, ABB, Universal Robot, whoever it is, like it's just traditionally very locked down. Maybe you are less so. And then the other ones I think are opening up more with like Ross drivers and stuff like that, it seems. But
yeah.
What you guys did that was so incredible was there's this demo, and basically I think you called it the Twister demo, right? So you have buttons and robots, and the user, in this case me, got to pick different positions that I wanted the robots to hit on this grid, and then without crashing into each other, which is way harder than it sounds for somebody that has never programmed an industrial robot or been around one. These things went over each other and around each other, and were able to hit all these buttons and do it in lightning speed. Like it's super cool.
Yeah, it's a great demo. We did nickname it Twister. We actually brought it all the way up to Automate in May there in Detroit.
I saw it there too.
Yeah. We have a great guy in the office who designed, built, and programmed that. And by the nature of our software, the whole point, the existence of our company is to make industrial robot programming easier, faster, and by default more economical. And what we were doing was we always had visitors, could be potential partners or investors or customers, and we didn't have a cool demo, and we bring them into the conference room and bore them to death with 50 PowerPoint slides, trying to tell them what we did.
Been there.
Yeah. And
unfortunately.
And it was quite a waste of time and not that interesting for most involved. And we made a decision. We got to build a demo that tells the story, or tells a big portion of the story of what we do. And there's 2 demos there, which tell 2 important stories of what we do. And so most of the time now, when you come into the building, the demos are in the entrance, as you remember.
Yeah.
And so you don't make it to the conference room because it's much more fun to hang out with the robots and press buttons. But you're right. It tells the story, if I may.
Of course.
That the software is robot agnostic. And what it does is it auto-generates collision-free motion plans for industrial robots and cobots. And we needed to find a way to kind of show off all of the main value propositions. Okay, so one of them is, as you said, there's 4 different robot brands all on this table, plinths, working really closely together. So a lot of opportunity to crash into each other, right? And so that you don't often see robots so close because it's so difficult to program manually. And okay, so it's robot agnostic. And then they're very close. So how do you program them that they don't collide? And how can we prove to visitors that programming them now is easy and it's auto-generated and people don't have to waste hours and days and weeks and quarters programming industrial robots when they could actually be working on something more valuable, like the process that they're involved in. So we allow visitors to use the interface in the touch screen, and there's light targets there. It's like the equivalent of spot welding, but in a fun kind of Twister demo kind of format. And when you do the math, actually, there's 4 robots, and I think there's 17 targets. So the number of possible permutations to send robots to each target is north of, 1.7 million or something like that. So it's very interactive, and you can come in and just allocate the targets per robot and then hit go. And there's no delay. Those robots will fly.
It just figures it out.
Full speed to the targets without colliding with fixtures and without colliding with themselves. And then we added a new cool feature on top of it, which was Resolver, which is what we just launched at Automate, which is this hyper efficient optimization software. So when you come and you allocate the targets per robots, you'll get a certain cycle time, let's say 17 seconds. And then we'll say, okay, well done, human. Now will that Resolver do it? And Resolver will come up with the most efficient target sequences and target allocations and motions for those robots to take, and it typically cracks it in somewhere between 5 and 6 seconds.
Oh, wow.
And that humans might be able to get there, but it'll take them a very long time to figure it out. Yep. So it tells the story, and it's so impactful when people stop by. We don't have to explain it using PowerPoint. They get it straight away. And then the other demo is pretty cool as well, which uses cameras, and you can stick your arm in there and those robots will avoid you but keep going. Yep.
That's awesome.
Yeah, it's cool.
Yeah, really, really cool. Well, again, I mean, I appreciate sort of the intention that goes into something like that. Thinking about like, what are we actually trying to show with this demo? What's the most effective way to show that?
Yeah.
Now, like, all right, let's invite people in. Like, get the world to see this thing.
What's interesting about it is we had a really great booth up in Automate in Detroit, and in a very good location as well. And if you're not in robotics and you see this thing, you're like, okay, cool. I don't understand it, but whatever. If you're in robotics, it's mind blowing because you never see it. It's like, how do you do that? That's impossible.
You guys are like the only ones that I've seen that are able to do that. Like it's.
Yeah, there's a lot of people can do path planning for single robots at certain speeds and applications and so on. But we're the only game in town that will give you those collision free for multi-robot, and if you mix brands or not, it doesn't matter. And it's a really difficult thing to do. And the phenomenal team that we have, from the guys coming out of Duke and then the team that's come into the company since then, have cheesed so much. It's mind blowing. Yeah.
No, I completely agree. What I thought was really cool, and if I'm not supposed to say this, just beep it out. But the fact that you're actually reserving an area for a robot, that becomes an obstacle. Now the other robot's like, okay, I'm going to go, but I can't go there because there's a thing there I can't hit.
Oh, that's public information. That's
I figured as much, but I just wanted to be sure. That's
exactly how it works. And think of all of the robots are connected to the same brain, and we can do that all in simulation and offline programming, but then we can transfer that to the actual physical robots as you've seen with the demo. And so we'll think of us as a very sophisticated navigation system, and we'll be sending the robot controllers paths and waypoints, certain commands that they need to follow, and the robot controllers themselves, like the FANUC and the AB, they'll control their own robot. They're doing the drive. But we do connect to the encoders of the robots as well, so that we're constantly monitoring the actual position of the robots. So it's this constant collision checking that we do. So if we're sending them a path to follow, we're actually checking all the time if they're physically following the path or if they're deviating from it. But yeah, the way it works is the central brain, and the robot will plan and move, and similar to you moving your arm to pick up a drink, a glass of water or something like that, you're going to occupy physical three-dimensional space. It's that three-dimensional space then that gets reserved. And the other robots, because they're all connected to the same software, they recognize that space is reserved, and they will find a different path to get to their target. So you can do all that very efficiently and pre-program it to come up with the best sequences, which is wonderful for car manufacturing, because you want to pre-program everything in advance, get the best cycle time, and then mass produce.
And just run it over and over again.
High volume, just repeat.
That's where Resolver comes in.
That's where Resolver comes in. And we leverage the cloud to get that, super efficient results. But where the name comes from is Realtime Robotics, is where we started, is in dynamic applications where you actually involve vision systems, for example. Take point cloud, convert that into that, let's say, three-dimensional space reservation. And so
the voxel thing, basically.
Yeah, think of them as three-dimensional pixels, we call voxels. So you get the voxel reservation, which the robots, you can see it on the screen, it'll light up as a cloud, and the robot will fill that space that is reserved. So in a dynamic application, if something alien enters the scene that has not been modeled before, it could be your arm, it could be a part that's coming in, it could be a palletizing application where you're placing packages on the pallet, but those packages automatically become an obstacle for the robots the next time they pass through. So if the vision system's picking up on it, we convert that box or that package into reserved space. So the software just thinks it's another robot, and it will auto generate collision-free paths to get to its destination on the fly.
Awesome.
Yeah, and that's where we started, and hence the name Realtime Robotics. Yeah.
That's really cool.
Yeah.
Now, I mean, I'm sure this comes up, and this is just me nerding out and being interested in the tech, but say there's something on that pallet that you want to grab. Is there a way to be like, no, that's okay to grab. That's not another robot, or, you know, how do you guys handle that sort of case?
Yeah, so there's some tricks to do that, and it's counterintuitive because the software is just designed to prevent collisions. But the robot, you've got to think about a robot as just a transportation device, vehicle to take the end effector to its destination. If you do a spot weld, you have to physically touch the part, the metal. So
Yeah, otherwise it won't work.
Otherwise, you're not going to weld anything. It's a collision in a very controlled way. It's a controlled collision. If you have a suction head that's picking up box, it's a controlled collision. So if you think of us as like an Uber system that we'll take you automatically to your location, let's say your apartment or your house. We'll take you to your gate on the road, but it's up to you to walk the last couple of yards to your door and go in. We're not going to do that for you. So, so we offer the users of our tools, system integrators and machine builders and the likes, that they can configure the tool to allow for those collisions to happen, and we'll get them to a certain point, and then they'll take over. And
well, that's interesting. So it's almost outside of your scope at that point.
Yeah, again, we're the Uber driver. We're like an autonomous, self-navigating Uber driver. You don't have to worry about getting it. We'll get you to where you want to get to, but it's up to you to work your process out once you get there.
That's pretty, and it actually makes a lot of sense. So if I'm trying to get to target, okay, so if I don't know how to get to a dynamic target, like I still need to figure out how to get to a dynamic target if I want to work with RTR. RTR will get me around all the stuff to get to that target.
Yeah.
But I still go to acquire the thing and get there. So if I've got like a wrist camera or whatever and I servo in, that'll work. RTR will get me there up to that point, and then I have to servo in on the thing. If I know what I'm trying to get to, because it's like a fixture, then I can do, you know, global coordinate frame stuff to get to that fixture. But, you know, RTR will get me around, you know, stuff that's not fixed, you know, like forklifts or whatever drives through the scene.
Yeah, exactly. And we do support, you know, 6 degree of freedom articulated arms, but 7-axis is no problem. So either on a rail or the end effector itself, which might be a servo gun, something that needs to, actuate. And we'll model that. And that will become an extension of the robot. So all of that end effector, whether it's a weld gun or a gripper or a suction gripper or something like that, is for all intents and purposes for us modeled as part of the robot, and so that becomes like a collision-free space reservation again. Now we will offer the users the opportunity to actuate that and actually have a controlled collision and set targets and frames in the system so that it does actually make contact.
Okay, so you still allow them the idea or the ability to designate a target and contact it within your framework.
That's right. Yep.
They have to just switch states. It's a different state in a state machine, effectively. They're like, okay, now we're ready to do a thing that contacts the environment.
That's one way. That's a good way to think about it. Yeah.
That makes a lot of sense.
Yeah.
Okay, cool.
So yeah, just try to keep it flexible. You got to think of us as we're not there to offer application solutions. We've worked on a lot of applications, whether it be multi-robot, mixed case palletizers, or spot welding, inspection, multi-robot, single robot, multi-robot inspection systems. I could keep going. And we've got ourselves into some really interesting, very complex applications. I'll share one of them in a minute with you. But we don't solve the application problem. We're a tool provider, and we solve the problem of complex motion planning, collision-free. Just take that off the table so that everybody else can focus on solving the application. And what's good about that is that we not only are we hardware agnostic, we're a pure software company. We can operate with all of the different robot vendors. but we can we can bring value across all of these different applications. And we happen to be focused very heavily on automotive manufacturing, on the high volume kind of spot welding lines. In the logistics space, we've got good track record. But you're going to see this in agriculture. You're going to see this in all sorts of, very eclectic mix of applications. And not only that, so we want to be a tool provider for the industry. And we've got to make that set of tools usable for end users, but also make it easy to integrate. So if there's other companies out there, kind of a B2B approach, let's say you're a vision company and your customers are asking for some kind of, motion planning, a full solution, including robot arms, feel free to license our software, access through the API. We're open for all sorts of partnerships in that sense.
That's incredible.
Yeah.
Awesome.
Yeah.
So what are some of the other areas that you see kind of either you guys going into or just being, up and coming for the robotics industry as a whole?
As I mentioned, there's a strong focus from our side on automotive manufacturing. And what's interesting about that is there's two big kind of geopolitical macro events or trends that are happening. One is the response of the consumer to electric vehicles in certain countries, and then tariffs. And that's actually obviously caused a lot of concern, a lot of deep thinking and replanning.
Sure.
Of
for me too.
Manufacturing, of where we're going to build these models. Are we going to reintroduce them back into the US? What's the mix going to be? And that kind of put projects on pause, I would say, for the most part. That's starting to kind of work its way through. But it also created an enormous opportunity for Resolver because the industry, both the OEMs and their line builders, had a little bit more time to go test Resolver. And they've tested it globally. They've tested it extensively. They helped us improve it as well over the last year before we released it to the market. And but you can also see that Resolver is so powerful, not just for path planning at the simulation phase of the project, of the line building project, but there's even more value upstream. And even at the proposal phase where line builders are trying to estimate the number of robots that they're going to need for the new line, are they going to be able to hit the cycle time that they've been asked? Even the position of the robots, the layout of the mechanical design. Can I use less robots if I position them this way? And what Resolver can do for them is tell them with a high degree of accuracy up front if that's possible, and will the robots reach their targets. Another great example is I've got 20 weld guns in my library. Which ones are going to work for this particular work cell? And Resolver, through the power of the cloud and calculation, in a blink of an eye, you're talking getting results in minutes, hours if you want to let it run longer and get even better results. But Resolver will tell you, 8 out of those 20 weld guns are going to work in this application. So you don't need to spend months trying to figure that out. And so you can get that up front. So now you can really plan that plant. Then you can really streamline your mechanical layout. Anyway, to get back to your question, so automotive is a big focus for us because Resolver is so impactful right now in the industry, where you're taking a pretty tough situation that they're in and you're offering them something that can really help them navigate their way out of it. But there are other applications out there. We are keen on the logistics space and enabling the palletizing, depalletizing type integrators. There is, interestingly, a demand for machine tending. So there's a pretty sizable CNC market out there. And again, that's getting into what used to be kind of higher volume, have CNC machines just churn out tens of thousands of parts for some of these high volume industries. But the tide has turned and there's a lot more demand for the high mix, low volume. And
you think fivefold?
Well, fivefold would be the overall non-automotive market.
Okay.
That's the bigger prize. But machine tending itself is an interesting.
But that's lots and lots of little markets stitched together. So if you want to grab one big one that looks like automotive, if you want to go into the next biggest one that looks like logistics, it sounds like if you want to go further than that and you aggregate those all together, it's a massive pie.
It's a massive pie. And so you got to start cherry picking and find, well, which ones have what in common and so on. That's part of the challenge moving forward. But we see a lot of demand for machine tending, having a robot actually pick up a part and load it into the CNC machine itself and do that more efficiently. So Resolver plays a role, but we can also use RapidPlan to control the robot. And even because if you think of the inside of a CNC machine, it's just a robot. It's just a multi-axis process. So you could control that as well and have the whole thing combined. The loading arm on the outside plus the CNC.
You could do that on a moving CNC machine.
You could, yeah.
That's
for cool. Us, it's just another robot axis set of axes that we would control. So we're discovering more quirky applications, but there's big markets out there like machine tending, which I think is going to be an interesting space for us as well. Yeah, no,
that is interesting. I briefly was the director of advanced projects for a company that doesn't exist anymore called FormLogic, and a Series A funded startup. And we were doing automated machine tending and just automating different manufacturing processes. We were loading and unloading. We had a space here in Pittsburgh that was like maybe a 30,000 square foot shop and a 20,000 square foot office. And we had something like, 30 CNC machines and a bunch of George Fisher System 3Rs on rails that were loading and unloading. I feel like with your software, like that would have been an interesting combination.
Yeah.
So
there's lots of potential there. Yeah. And I think also in inspection, so aerospace and defense, there's across a lot of industries, there's a lot of inspection systems where you've got typically a single robot, but you're scanning a particular part or surface area or whatever it is. And I think that's an easy one for us as well. We've just we're completing a pretty heavy duty project, and it's actually for railway car manufacturing where there's tens of thousands of spot welds. So compared to a commercial vehicle or a consumer vehicle where there's a couple of thousand welds, you're looking at tens of thousands for a railway car. So
many spot welds.
Yes, and if you change the design of each car, this car is the restaurant car, this car is first class, this car has a bathroom in this corner, it actually changes the structure of the floor plan and the chassis and where the weld points go. And so can you imagine humans trying to manually program 25,000 spot welds?
I feel like you would just want to do it by hand at that point, like just to save the programming time.
Yeah, right. But then you have to change something. And you have to go back and redo it all. And you have to re-verify everything, revalidate everything. And what was happening in the application is that, so RapidPlan was employed to do this automatically, which just saved them a ton of time. And they then modified the design and RapidPlan would just auto regenerate new motions. But what they found with these huge robot weld guns that on the steel, there was material deformation happening with the weld because of the temperatures involved. And RapidPlan actually needs a digital twin for this. So we need to have an accurate location of the targets. But if the physical target now moves because the sheet metal has deformed, we're going to jog the robot to the wrong spot. Now, it might just be 2 millimeters off.
But I mean, that matters.
But that matters. And we didn't do it. The integrator was clever enough to introduce a camera system and write some software to detect that deformation and live in the loop calculate that change, feed that back into RapidPlan, which resides locally at the system level, and RapidPlan would compensate for that change in real time. And that was something that they discovered that they could do.
So they're just running it again, effectively, after the weld is done on a new digital twin.
And you don't really need to do any revalidation of that because the change is so minute. You're not going to cause a collision with something or another robot, but you will get that recalibrated well point, and we'll take the robot exactly where
So
it
it's
needs to be.
parameterized where you can cut out a lot of the overhead and just say, hey, it's going to be slightly different. Can you effectively give me the same path? But,
Yes, but the last millimeter will adjust.
that's pretty cool.
Yeah, because we've been told to. And there's another example of where we need the integrator, the machine builder, to tell us where you want sorry to go. So you can either tell us manually and program it into the tool, or you can have another system that's calculating it and sending it through. And that can come through a vision system or a PLC or whatever. And we'll take that information and we'll adopt the in real time the motion plan to get you there.
Pretty cool.
Yeah.
Awesome. Well, I feel like that's like a pretty clean note to end on. I mean, this is a great vision for the present. Now, I wouldn't even call it the future because you guys are doing it.
We're doing it, yeah.
As we kind of like near the end of the episode, is there anything, you want to plug on the way out? Obviously, we've been talking about RTR the whole time, so I feel like it's an awkward question, but maybe a closing, kind of thought for people to take with them, something to think about, just food for thought.
Yeah, well, I appreciate the opportunity to come and talk to you about it. And it's an exciting time for us. Resolver is the big thing right now, but it's good for those kind of high volume, pre-planned applications. We're finding Resolver is becoming useful in many other applications, many of which we haven't discovered yet. But just know that there are tools out there now that just simplify this and democratize robots and will enable the industry to start using these things. And if you're ever in the Boston area, we're in the seaport. We're not that far from the airport. The door is always open. The demos are awesome.
Yeah, I agree.
Come and see us. And we'll just keep getting the word out there. The future looks great for us. I think our ultimate selfish goal is to be the default motion planning engine in all robotic systems. And we're trying to drag the industry into the 21st century. Humans programming robots are limited. And the skills, you need a lot of experience to do it really well. Your job's not going to go away because the physical robot implementation is still going to be key, and all of the application that goes around it, keeping those things running. But spending your time, the human brain is limited in terms of it doesn't understand robot kinematics, joint kinematics. Our software does. That's why our software would generate motion plans that humans wouldn't even think of. You see some of the videos of it. It's counterintuitive. So anyway, I would say that the 21st century has arrived finally after 30 years of industry trying to figure this out. And the sooner you start adopting these new tools, the better. And you're going to be able to use robots where you didn't think you could before because it wasn't economical. Now it is. And most importantly, in many of those applications we talked about, you will never see more than one robot. It's a single robot application because two robots it's too complicated. We make that easy.
Awesome.
And so just to let everybody know out there that if you have an application where you think your throughput will double if you add another robot, you can now do it without an exponential cost adder to it.
That's incredible.
Yeah.
I'm thinking about it with palletizing too, right? You have 6 robots unloading a pallet. That's awesome.
Yeah. So I think that's another space where there's a lot of investment in robotic systems and automation. Very much single robot for the moment, fairly limited. But again, we're changing the game there. So
that's incredible, Kevin.
Yeah.
Hey, thank you for coming on, sir.
Yeah, thank you. Right. Appreciate it.
Appreciate you. Thanks for joining us today. If you've made it this far, chances are you'll like other episodes too. Collaborative with Spencer Krause can be found on YouTube, Google Podcasts, Spotify, Apple Podcasts, Pocket Casts, and Radio Public. Subscribe today to get notified when the latest episodes release and support the channel. Have an idea for a guest I should interview? Hop in the comments and let me know who that is. I'm always looking for new people to talk to, and chances are you know folks that I don't yet. Thanks for coming in, and I'll see you on the next one. Collaborative with Spencer Krause is sponsored by SKA Robotics. If you're in the market for elite field robotics expertise, please consider hiring SKA Robotics. They sponsor this podcast and solve some of the toughest engineering problems in the world. SKA Robotics can be found at skarobotics.com.